Hello, this is Team 3, and this is our GATE 4.5 report over our project. Our team project is to design and build a device that will filter and clean water from forever chemicals, biocontaminants, and trace pharmaceuticals using UV light and TiO2. Our 8 team members in our project are Drake Farrell, who's a MET student, and he's our manufacturing development member. Zach Weiss, who's also an MET, who's our mechanical design leader. Nathan Marshall, who's in energy engineering technology and is our schedule manager. Natalie Coe, who's an EET, he's our electrical design leader. Ray Fuchsia, who's an IET and is our team secretary. Grant Clark, who's also an EET and is our testing and validation team member. Alex Lapari, who's our CET major, he's our programming lead. And finally, Ilya Sorter, who's NID and is our lead of product visualization. Now that we've laid the foundation by introducing the members in our project, we can dive deeper into our scope of work and method. Our design requirements is to create a refined version of the photocatalytic reactor, which we created last semester in ENGT 480. Our 2 designs that we narrowed down are our Donkey Kong aqueduct system and our fountain. Our major client needs that we have been tasked with are to be dealing with the decontamination and the efficiency of our design. We've put a goal down by the end of our project to get a 100% efficiency with the decontamination, and that is something that we've been on track with. Also, another major need from the client is the scalability of both designs to reach a wide target audience. Scalability and cost efficiency, the client needs the requirements. Another project criteria that we've been using is a 10 gallon per minute minimum, which is something that we've easily handled. Our pump with the least amount of gallons per minute is at 11 right now, so that's something that we've been using as a good boundary. Our development costs are to be kept as low as possible for the materials while retaining as little custom parts ordered for the design as possible. Now we've realized that this is a hard goal to meet, but we've been trying our best to keep costs low for the university.
There have been a number of previous attempts to purify water using TiO2 and UV light. The figures on this slide show 2 previous attempts done by different groups. The primary concern with the different designs is the various methods of dispersing water over the surfaces coated with TiO2. Ideally, there should be less than 1 millimeter worth of water density over the coated surface to ensure that all the water flowing over the surfaces are making good contact with the TiO2. Generally speaking, UV light exposure is less of a problem in this sense. Effectively, the purification rate of these designs is limited by the exposure to the UV light, as well as maintaining that thin flow of water over the surfaces. So our designs are going to be primarily focused on maintaining a thin stream of water flow to ensure that all the water molecules within that flow are making contact with the surfaces.
Our first design, the glass bead fountain, uses TiO2 covered beads and UVC lights to decontaminate the water. The design pumps water in from below, up the center pipe, and begins its UV light exposure. The water moves upwards through the upper funnel, cascading down into the second larger tube. The water then falls through the internally covered TiO2 tube, beginning the reaction as the UV light hits the water. The water then reaches the TiO2 beads, filtering through them, slowing the water movement, but vastly increasing the TiO2 reaction with the contaminants. The water is then filtered down through the thin steel mesh and returns to the basin to be rerun until all the contaminants are removed.
Our next design, what we call as the DK Aqueduct design, is a multi-stage glass pane design built from aluminum extrusion, and the panes will be set in a way to where water will flow through the system using gravity, while these glass panes will be coated within TiO2. From the first stage to the last stage, as it hits the tub. The water pump at the very end of the design will pump the water back up, thus restarting the process. All the while having UV lights either as a strip or as a bulb, decontaminating the water in the process.
As far as the results from our first test, we started with the marble design. 11 liters of contaminated water were added over a 1.5 hour period. You can see that in the chart on the bottom left as it makes its way to 100% contamination. 15% of the contaminants were eliminated 1 hour after contaminants were fully added, and 100% of contaminants within the marble design were removed after 4 hours. The graph on the bottom left is a great representation to see the curve line of this. And then for the DK design, 22 liters of contaminated water were added over 1.5 hours. 10% of the contaminants were eliminated 1 hour after contaminants were fully added, and 100% of the contaminants within the DK design were removed after 5.5 hours, again represented in the curve in the bottom right. Following this, you have the videos of both designs from our first prototypes on video here, as you will see here.
Okay, the pump's finally kicked in completely. You can see at the bottom that the level of the water inside the tube is about 1 inch higher now than the outside the tube, which is what we need. Now we're getting pretty much 360 degree almost. There's a couple areas of the water. Okay, it's working great now. I was just sending you a video.